All right, chemistry people, we are going to do some more notes today. Let's see, is that the workbook I want? I'm not sure it is. This is the workbook I want. Here we go. Let's open up this. So when we left off last time, we were talking about SI, base units, and we were talking about what we use in the metric system. Once again, I want to go over those really quick. We use seconds for time, meter for distance, grams or kilograms we usually use for mass. A lot of people will confuse that with weight. Weight and mass are a little bit different. For temperature, we will use Kelvin or Celsius, usually Celsius, but sometimes Kelvin. For the amount of substance, we will use a mole. We will talk about moles a little bit later in the year. I would think probably the end of second quarter, maybe even into third quarter. And then for the electric current, we will use amps. And for how bright a light is, we will use candelas. You really won't use amperes or candelas until you get into physics. So, all right. So let's go on. Let's do our next stuff. So to better describe the range of possible measurements, scientists have added prefixes to these base units that we just talked about. These prefixes are based on units of 10. So for instance, I could go from a gram, and 10 times a gram would be a decagram. So I'm always jumping up by 10. And then 10 decagrams would be a hectogram. Okay? So let's get this. For instance, right here, a prefix kilo means 1,000. So an object of 5,000 grams could also be written as 5 kilograms. So in other words, there are 1,000 of the base unit in 1 kilogram. Okay? So next example, the prefix milli means 1/1000th with a th on the end. So that means that I would have 1,000 millimeters, for example, in 1 meter. Okay, so milli means smaller. It means that an object with a length of 0.00035, why did we do that? 0.00035 meters could also be written as 0.35 millimeters. Notice this becomes a lot easier to read than this. So we will use those different prefixes to help us make the base measurements either bigger or smaller depending on the measurement that we really need to measure, so that it makes it easier to read and easier to talk about. So here we go. Here are the prefixes. I would like you to know mega down to nano. Okay? Now notice that we have symbols that are just letters that go for the different sizes of the prefix. Notice all the ones that are bigger than the base unit all have capital letters, and the ones that are smaller than the base unit all have lowercase letters. And then we got this funky letter here in the middle. This is the Greek letter mu. It's kind of like a U with the tail on the wrong side of the U. Okay, so let's talk about each of these prefixes. Giga is 1 billion of the base units. So that's billion with a B, or in other words, 10 to the 9th of those base units. Mega is a million, or 10 to the 6th. Kilo means 1,000. We've already discussed that up there. So in other words, 10 to the 3. Then if you've noticed, I don't know if you've noticed, those of you who are wordsmiths, All of these larger base prefixes all come from Greek. They all have Greek prefixes. Okay? And then let's talk about the smaller ones. So deci means 1/10. So I could say 1 divided by 10 or 10 to the negative 1. Centi. Let's think about the Latin here. Deci, decade. Decade is 10 years. So deci would be 1/10. Centi. What is a century? A century is 100 years. So centi is 1/100th. Okay, or 10 to the negative 2. Milli, a millennium is 1,000 years. So milli is 1 out of 1,000, or 10 to the negative 3. Micro is 1 out of 1,000,000, or 1/1,000,000th, so 10 to the negative 6. Nano is 1 out of 1,000,000,000 with a B, so 10 to the negative 9th. And pico is 1 out of 1,000,000,000,000. So this gets super small when we're measuring pico anything. Okay? Now, those of you who are wordsmiths, did you notice that all of the prefixes that are smaller than the base unit, these all come from Latin? Okay, so if you know your root words, if you know that that root comes from Greek, you know it's bigger than the base unit. And if you see that it comes from Latin, you know that it's smaller than the base unit. So that's another hint. Once again, another hint is the capital letters right here. Those are always going to be bigger than the base unit. And the lowercase letters, those are always going to be smaller than the base unit. So there's 2 different ways that you can look at that to give you hints. Okay, so let's talk about what is the name for 1/10 of a meter. So let's look at this. So this is 1/10 right here, and we say it's deci. So I would say this is a decimeter. Okay, so my next question is, if I formed a cubic box with this unit on its edge, what would be the volume of this box? So I'm going to draw a box, and it's not going to be wonderful because I can't draw very well, especially on this tablet. Okay, so if I have a box here where, let's change my color here, where I have one side that is 1 decimeter, and I have another side that is a decimeter. And then my last side is the depth, that is also a decimeter. Remember, if I want to find the volume of something is the length times the width times the height. So my length is 1 decimeter, my height is a decimeter. So if I take 1 decimeter for my length, multiply it by 1 decimeter for my width, and multiply it by 1 decimeter for my height, 1 times 1 times 1 is still 1. But then my unit, that would be squared, right? 1 times 1, that would square it, times another one would be cubed. So I would get 1 decimeter cubed for my answer here. Okay, so this is a volume that we use a lot, even here in the United States, where we really don't use the metric system. We sell something by this measurement quite a lot, actually. So think about it for a second. See if you can think of a guess. Okay? So we sell soda pop by this. And if you buy soda pop, you're usually buying it in liter or 2 liter or even half liter bottles. So 1 decimeter cubed is equal to 1 liter. That is the definition. Okay, so if you think of this, think about a decimeter. It's only about 10 centimeters long. In fact, a decimeter is 10 centimeters long. So if I have 10 centimeters by 10 centimeters by 10 centimeters, I will have a box roughly that size. That's a liter. So if you take a 2-liter bottle and divide it in half, that will basically give you a decimeter cubed. Okay? Let's do this same drawing, but let's use centimeters this time. So remember, in 1 decimeter, I have 10 centimeters, right? So that would give me 10 centimeters on each side. So if I draw this box with centimeters instead, let's do this. So I'm going to change my color again so it gets a little less confusing. So 10 centimeters on this side, 10 centimeters on this side, and 10 centimeters on this side. Once again, if I want to find my volume, it's going to be length times width times height. So let's do this. My length here is 10 centimeters. My width here is also 10 centimeters. And my height here is also 10 centimeters. So let's think about this. 10 times 10 is 100. 100 times 10 is 1,000. So this will give me 1,000. And then centimeter times centimeter will give me centimeters squared times centimeter again will give me centimeters cubed. So I will have 1,000 centimeters cubed. Ooh, didn't we just say that that was also the size of a liter? So that means I have 1,000 centimeters cubed in a liter. Did you guys know that? So let's look at this next thing. So the volume of the cube in centimeters cubed was 1,000 centimeters cubed. So how many milliliters are in a liter? Milli means 1,000, right? So when 1 liter, I'm going to have 1,000 milliliters. So 1,000 milliliters is going to equal a liter as well. So does that mean that centimeters cubed and milliliters are the same? Yes, it does. So a centimeter cubed is a milliliter. So here is the big idea here. A decimeter cubed is equal to 1,000 centimeters cubed is also equal to a liter is also equal to 1,000 milliliters. So a centimeter cubed is the same as a milliliter. All of these are equivalent to each other. We will use these equivalencies a lot in this class. So this is probably something that you want to star or highlight. Let's actually highlight this because it is worth highlighting. We will use this a lot. I mean a lot. Okay, that is something that we will use a lot in this year to convert between different units. Okay, so here we go. We're going to do some practice using these conversions and using the metric prefixes. Okay, now we'll do some conversions involving just the metric system. This process is called dimensional analysis. Some teachers also call it unit analysis. Oh, and I can't spell. Do you ever get to the point that you can't spell? Okay, let's try that again. And some teachers actually call this factor label. Okay, my chemistry teacher called it factor label all the time. And I think I misspelled label. I can't spell either. So you'll notice a lot of times that I misspell things. That's okay. It just shows you my dyslexia. Okay, yes, your teacher has mild dyslexia, and it was, we all have our learning disabilities, and that's my learning disability. Didn't mean that I couldn't learn, though. Okay, so here we go. Convert 4.75 grams to milligrams. So the first thing I want to know is how many grams are in a milligram, or vice versa. How many milligrams are in a gram? So the first thing we have to look and see is which one is larger. So let's go back up to this chart. Okay, milli is smaller. Milli is smaller than gram. So remember, gram is our base unit. So our base unit here will be grams, it will be meters, or liters. Those are going to be the base units that we are going to use this year. So I know that there are 1,000 grams or milligrams is equal to 1 gram here because it's 1/1000th. So to make 1 gram, I'm going to need 1,000 of these little ones. Okay, so I need to use that conversion here. So I know that I have 1,000 milligrams equal to 1 gram. Now, the thing about unit analysis or dimensional analysis is we are going to use units kind of like x's or y's in an algebraic equation. We're going to use them as part of our variables. So remember when you were doing fractions in algebra, or I guess you guys don't do algebra anymore. You do secondary math 1, 2, and 3. If I had a fraction that had a 4 over a 4, can I reduce this fraction? I can. So they both have a common factor of 4. So 4 divided by 4 would be 1 over 1. So this would give me 1. Now notice when I have numbers, they actually reduce. But if I have units that are the same units over another unit, that unit actually cancels out, meaning we don't have that unit at all anymore. It's gone. Okay, so the name of the game with dimensional analysis or unit analysis is making sure that on one side of the problem, we have the unit on the opposite side of our next step. So we're trying to cancel out units to get into the unit that we want. So I am starting in grams. That means I want to cancel grams out, and I'm asking about milligrams. So I want milligrams to be on the top of my last step. So I have grams here on the top. And so the next step to get it to cancel out, I need to have grams on the bottom. So in this equivalence, I'm going to put 1 gram on the bottom is equal to 1,000 milligrams on top. So that helps me cancel out my unit of grams. I'm going to draw a better G. So notice that G, I didn't really need to write it down, will cancel. So I have G on top for grams, and I have G on the bottom right here for grams. So they will cancel. And the only unit I have left here when I'm all said and done is milligrams. And that's what I wanted to end up with. So that's good. Now we have to do the math part. So let's look at the math. So everything math-wise that we come across at the top, we're going to use as a multiplier. We're going to multiply all the numbers on the top, and any number that we have on the bottom, we're going to use it as a divider. Okay, so let's look at this. We're going to take 4.75, we're going to multiply it by 1,000 and divide by 1. Now, anybody that knows dividing by 1, that's the identity property of division, isn't it? So that just gives us the normal number. So really, we only have to focus on the 4.75 right here and the 1,000 right here to multiply them. So 4.75 multiplied by 1,000 will give me 4,750, and then my milligrams. You can put a comma there if you want, if not. So make sure you end up with the unit being left over that you want, and then just do the math. Okay, let's try another one. I'm going to change my pen again. So convert 89.43 liters to nanoliters. So once again, I need to figure out the relationship between liters, which is our base unit, and nano. Now, nano is Latin, so I know it's smaller. How small? Let's see. Nano is 10 to the it's 10 to the 9th. There's a billion. There's 1 billion nanometers or nanoliters in 1 liter. So I would need a billion. So in 1 liter, I would have a billion or 10 to the 9th. So notice I took that negative and took it off because I would need 1 billion of those tiny, tiny little nanoliters to make 1 liter. Okay? So notice my units. I have liters on top and liters on bottom. So they cancel out. What I have left is nanoliters. That's what I want. Okay? Once again, everything on this top, we are going to multiply by, and everything on the bottom, we are going to divide by. But once again, dividing by 1 just gets us the same number, so we really don't have to pay attention to it. So 89.43 multiplied by a billion. That's going to give us 8.943 times 10 to the 10th. Now, some of you will not know how to do this exponent. So I don't know if I can show you really quick. Let's see if I can get my camera here. So let's move my camera around. So if I look at this, if I have 89.43 and I want to multiply it by 10 to the 9th, I'm going to type in 10. And do you see this caret key right here? That will give me that exponent, and I'm going to put an exponent of 9 there. And then I'm going to hit enter, and notice I have 8.943 times 10. That E is times 10 to the 10th. That number after the E tells me the exponent on that 10. So that's how you put things into your calculator. If you have any questions on that, please come and see me. I'm happy to help you with that. Okay? Let's do another example here. Okay. Convert 3.44 times 10 to the 4th seconds to megaseconds. Notice we have a capital M. So that means it is bigger. Mega is a million. So in 1 megasecond, I'm going to have 1 million seconds, or 10 to the 6th seconds. Okay, so that's the unit that I'm going to be using to convert. So let's look at this. Let's set this up. We're going to start with a number that I know, 3.44 times 10 to the 4th seconds. And I want my seconds to cancel. So I'm going to put seconds here of my conversion on the bottom. So I'm going to have 10 to the 6th seconds will give me 1 megasecond. Okay, so let's look at our units here. I have seconds on top and seconds on the bottom, so they're going to cancel out. The only unit that I have left then is megaseconds, and that's exactly what I'm asking for. So that's what I wanted to know, right? So let's look at the math now. So if I look at the math, Let's change color here. If I look at the math, I am going to multiply this. So 3.44 times 10 to the fourth times 1 is just going to be 3.44 times 10 to the fourth. It doesn't change the number, right? Because that's the identity property of multiplication. But all of this, we actually have a number that we're going to divide by. We're going to divide by 1,000,000 or 10 to the sixth. So I don't know if your teacher has told you this, but when you have base 10 with just 1 by it, right? This is 1 times 10 to the sixth. You can basically just take these exponents, the 4 and the 6, and if you have one on top of the other, you just subtract the top and the bottom. So 4 minus 6 gives me a -2. So this is going to be 3.44 times 10 to the -2. And then our unit that's left is megasecond. So if you wanted to look on the calculator, if you put this on your calculator, this is what would come up. Notice I had 2 spaces to get that decimal place to look like this. So this is both ways of putting this. So this is in scientific notation, and this is in normal notation. We're going to be working on this for a bit. So happy converting to metric system, and we'll do some practice tomorrow. We'll see you. Bye.